Hello and welcome back everyone. Today I'm going to show you how to create a fully custom MetaHumans and how to implement them and replicate them in Blender without any paid add-on or plugin. In this video you will learn how to convert your existing non-MetaHuman character to a fully functional MetaHuman, how to modify existing MetaHumans, how to remove and change and bring back underwear, how to recreate MetaHuman materials in Blender in a cheap and easy way, how to modify baked engine standard masks, RGBA pack textures, and how to manipulate complex normals, how to export and import Groom assets in between Unreal and Blender, and from Blender to Unreal, how to modify existing Unreal-based Groom assets, how to create fully custom strand-based Groom assets with a fully custom hair color, how to generate haircards and helmets, how to create resizable outfits and yes, grooms as well for MetaHumans, how to get the 52 ARKit shape keys to your MetaHuman, how to get highly complex MetaHuman rig-based ROM or any animations from Unreal to Blender. The one thing we don't touch is how to create a control rig in Blender, which would be a total no-brainer and totally pointless in my opinion. Obviously the MetaHuman you want doesn't have to be a custom at all, it can be any presets it comes with. However, this is the best approach to show you everything all at once. I will try to limit high-end technical speech about the topics to keep things simple as possible, but it's going to be complicated. It will be a lot of back and forth between platforms and I have a lot of things to cover, so let's start this. First and foremost, we will need various plugins and add-ons on the road, but as I said, they are all free and accessible. First thing we will need is this file from Fab, MetaHuman Comfort Topology. You just download it and unzip it. This is a quad-based MetaHuman topology for, as the title says, conform the MetaHuman head and the body. Next one, the Groom exporter from Gumroad. This will allow us to export hair curves from Blender to Unreal. Next up is Groom exporter, but from Unreal. This is the one that I will use. You have to create an account and just download it. There are additional true Groom exporters from Unreal, but the time I recorded this, these were not worked for me at all. This one is free, and there is a Fab version here, which is a paid version, and you even probably need a VPN for this to access it. So I not recommend this one. So in Blender I installed it the usual way and off screen I created a unique head sculpt for Avril. The scale is all 1 and it's enormous, but it doesn't matter, this can be a face scan as well. My scene is set to Unreal measurement, which is 0.01. As always, it's a really good idea to set it in the beginning of the project to avoid any scaling issues, as I said it many times. But if it's on Blender measurement on 1, it's not going to be a big deal, but you will need to look out for scaling, but I will mention it frequently. The unique head sculpt part isn't necessary at all, it just allows me to cover every possible scenario you want to work with. Obviously it will give you a way greater creative control on how your character face will look like. The geometry doesn't matter, if you already have a different kind of head, it can be whatever kind of head. For example, I pull in the female character from the free asset pack from Blender. I will just create a seam, select it with L and separate it. This is the kind of head we would need. If you want a specific preset or a created MetaHuman head, just get into your project and export it out as an FBX. In Blender, just import it, clear the parent and remove the modifier. And now you have your base head. Again, the geometry in this case doesn't matter. If it doesn't make sense yet, it will, I promise. So I will just export my bootleg Avril head as a simple FBX with these settings. In a new Unreal 5.6 project, I import our head FBX as a simple static mesh. We don't necessarily need any materials. In the plugins, look for MetaHuman and tick in everything. It will need a restart. Once that's done, look for a MetaHuman identity asset. Open it up and hit create component and look for your static head mesh model. Place the camera in front of the mesh and hit promote frame. Then hit track markers. In this section you have to align the shapes for the feature of the face. The eyes are usually the ones that are always messed up. I'm going to quickly align these with simply dragging the dots around the mouse and the eyes. If it's done, hit MetaHuman Identity Solve. When it's finished, in the B section you will be able to see the preview of your face mesh with the MetaHuman geometry. Even though it looks nicely quadified here, it will actually be triangulated when you want to export it as an FBX. And I said it, I don't go into real technical, but even if you are quadify the mesh in Blender, it will not work. And there is plenty of reasons why in the background, but more on this soon. But luckily, Unreal have a solution for this, and this is actually a simple command. Make sure you are in CMD, not Python, and start writing MI. And we are looking for this, identity export meshes. And as you can see, it's on false by default. To make it true, we just need a space and type in 1 and hit enter. Now we can see that it is true. That means whenever we hit the MetaHuman Identity Solve button, it will going to export this mesh as a quad mesh to our Unreal project folder. So I'm going to hit that again. When you open up your project folder, there is a saved folder here. Inside that you will see a variety of different files, but the one we will need is this one here. But before I import it to Blender, I will need a body as well. So I'm going to create a new MetaHuman character. Again, it will need a restart. Inside the creator, under the head, we should go to conform. Here we can use the DNA as a conform mesh and identity, which I just created. There is another template version, which I will use later, but I'm going to use identity now. Select it and untick these. Hit conform. Now that I have her head, now I just need a matching body. I'm going to use a simple blend version now, just to get the basic female body. This body needs to serve as a reference point only, so it doesn't have to be perfect. However, I want to specify something, and that is the height. So according to the internet people, Avril is either 156 or 157 centimeters. So I'm going with 157. Now the portions looks kind of awkward. I will try to manipulate this just a bit. It doesn't have to be perfect at all, as I said. Also, it's kind of weird to create it like this, even though it's supposed to be based on real human proportions. Okay, kind of fatty, but it doesn't matter now. It just have to have a close resemblance on what I actually want. Now I'm going to set up the skin and an eye makeup just for preview. Set up the eyes and some foundation. We can either totally replace or modify these textures in Blender. Since I don't need to fully recreate the textures, I can get something that's fairly fitting. Now let's add some grooms. From hair, which is the closest of what I'm looking for, is this long straight hair. I'm going to add an eyebrow and an eyelash. Now you can download the textures. Currently it doesn't matter which size, we can go with 2K. Up here we can export the combine mesh first, but I will talk about this later as well, why we would need that. Then export the body as well. Then export it out like so. Just for organizing, I'm going to copy the Conforma face mesh from the identity to my folder. Now in the same folder, I'm going to unzip the Conforma mesh topology as well. You should see a head and a body with a 4K texture in it. New folder, then place them in. In Blender, I'm going to import the identity, which is an OBJ. At the import, you should change these as so. And this is what you should see. If your scene is in Blender, you will need to scale down the object on all axes to 0.1. Not 100% sure about 0.1, but you have to scale it down for sure. Let's import the combined body and the body from the fab content. Now some quick explanations. So if you look at the combined mesh, you obviously already know, but everything is triangulated in the game engine. And it cannot quantify back or call back the original quad mesh. However, the engine triangulation did not change the count of the overall triangles. To prove that, I'm going to remove the combined mesh head parts now, turn on statistics, and you can see that they are perfect match. However, this Conforma mesh hold additional attribute data that the exported FBX mesh does not have. And without that info, the MetaHuman creator will give you an error if you would try to use this mesh as a template mesh inside the editor. So this is the main difference, and it's not that it's triangulated. Because in practice, we could turn this back to quad, just press F3 and look for trees to quads, and it will solve 90% of the work for us. We can modify these rates to get better results, but we would still need manual work on these certain places. Here you could check which triangles didn't make it. As you can see, it's really great, and you can actually fix this by hand and get the exact same tree count as the Forma mesh. But as I said, it doesn't going to work. The main difference is the built-in attributes. You see it more visually here at the identity OBJ mesh. This is one of the things that is missing among a few hidden ones. Therefore, we have to take caution to do not remove any of it. We can sculpt the head, but we can't remove anything from it or add any extra geometry. But first, let's handle the body. So now I will scale it down from the word grid center. Then I'm going to apply the scale modification. Then in sculpt mode, I'm going to match the Conforma body just to get the base easily. That's why I needed the combine mesh, so I can have the exact height reference and the base body shape. Other than the main features, I'm going to go and make this fully custom, since Unreal Sculpt version doesn't really allow me to make the important parts accurate. Now, if you're aiming for something wild with horns and so on, this is the time to do it. However, keep in mind that you cannot add extra faces, as I said before. If you're aiming for huge spikes, you should make them a separate mesh and later add it to the skeleton. In matter of fact, you can basically start your project just from the two fab provided Conforma meshes. However, as I said, in the case of faces, it doesn't really give you that creative freedom. Now I'm done with it, it's time for the head. I'm going to rotate it on the global Z by 90 degrees to align it with the rest of the body. But I don't want to move it from its original place and don't want to distort its origin position, nor apply the transform. What I want to do is to place the head I already have and do the same thing, just as at the body. We can change the shading and give it a material to be more visible. You can try to do that with shrink wrap, but it's hardly going to match, and it probably will turn out just like this. Or with an add-on, you can try to recreate it with UV mesh, but that's going to result additional distortions in the attributes, so there is not really a fast way of doing it. Just at the body, do not touch anything, because for example, if you remove the sharp, even here and in Unreal especially, you will receive some really horroristic look, so I'm going to undo that. So you can do it just like at the body when the original mesh was underneath, or just like me doing it side by side and fixing points where it's needed. There is also another way you can do the sculpting non-destructively, is to create a shape key. Set it to 1 and create anything you want. As I said, you can go fully custom here with horns or anything, but just like before, you are not allowed to add extra faces or vertices. I know I mentioned it a couple of times, but it's really important. And if you satisfied with it, you can just apply the shape key. But obviously I'm not need that right now, so I'm going to delete it. Make sure once again that the origin for both the head and the body is at the word grid center. Then you can go ahead and export both meshes as an FBX. It doesn't have to be an OBJ. As you see at the head, I didn't apply the rotation, I just left it as is, but the body scaling was applied. Create a folder in Unreal and import these assets. Again, import it as a simple static mesh, no material is needed. You can delete the textures as well. Save everything. And now in the creator, now we are able to use the template function. Make sure adapt neck is turned on. Here we can select the head we just created and hit conform mesh. Now the body, same thing. Use the template. You can leave it on from mesh and skeleton, then hit import, and we can see it worked. And we can see that I should have spent it more time with it. I also granted her some C cups instead of B, but I'm going to slightly fix some proportions regarding the arms, chest and neck and make it way more skinny. Okay, seems good to me. By the way, you can always hide and unhide grooms and outfits if you are not familiar with the editor. You can further tweak the character now with some extra sculpting. And depending on what you want to do with the skin textures, you can modify them as well. You can also remove the top as well. Now I'm going to look for an eyebrow that is sort of similar what I need, just like at the hair, same as with the eyelashes. Change the color of the lips just a bit. And since I want to create my own eye makeup, I'm going to remove this. Seems all okay. Now I'm going to download the textures in max quality. I'm going to switch to assembly and I'm going to create a full rig now. You can visually see the difference here. If you are using a medium spec PC, the optimized version, high quality settings is your best bet. It looks surprisingly close to a cinematic one, but the performance and the file size difference are huge. So I'm perfectly fine with the optimized one, so I'm going with that and hike settings and hit assemble. Now I have the folder right here with almost everything we need. But mainly what we are looking for are the baked textures. But we also need the DCC export version saved down as well. For that, change it here to DCC. And then select a folder, create a full separate place for it. Then hit assemble. Now it's going to export the DNA file and textures to that folder. I actually made a mistake, so I don't want the top, but it's a good thing that I made a mistake since you can see we can easily fix that. So in the creator, you can remove the rig anytime, then make changes, and you can reassemble the character once again. So I'm going to remove the rig, remove the top, download the textures once again, create the full rig, then assemble the character again at the same folder. And save down the DCC again, just in case. Now we can start exporting assets from our MetaHuman folder. Here, the export settings, we can bake the material inputs as well, with a simple and a mesh data. It's going to do something, but unfortunately, it's not a magic button. I'm going to use mesh data, for example. You can totally leave it on disabled. It will not provide us textures that we couldn't get manually from Unreal. I mainly do it just to show you what it does. Now the Groom. The Groom are a different story. In this tutorial we are focusing mainly on strand-based hair because it's way harder than cards, and I already talked about it in other videos. But if you don't want strands in Blender, your life becomes way much more easier, since you can just export these cards as an FBX and you can easily set up a material for it. But we are going in hard. As usual, Unreal doesn't make our life easy regarding Grooms, because as you can see, we cannot export this as an Alembic file. This export we are going to do nothing, so again we have to cheat a little here. But for future steps, let's go ahead and enable a plugin called Alembic Groom Importer. It will need a restart. Now we can't do anything here in an Unreal 5.6 project, unfortunately. We need to create an Unreal 5.5 project. Create a simple template. In the project, enable the MetaHuman plugins. Create a folder, import our face skeletal mesh we saved down. Create a MetaHuman identity, just like at the beginning. If you want everything to be precise, you should set up everything close as possible to the original, but I mainly need this because of the head shape itself. to be able to get the hair aligned with the scalp. I'm not really bothered by the eyelashes, since in my opinion it's a waste of effort to make it in Blender as strands. It's way easier with cards and with an identical result. But as I said, if you're into that, make it precise as you can. Or start your full project and your head mesh from here, from an Unreal 5.5 project. But it's kind of getting hectic if you want to move that head from the online creator to a 5.6 project. So I wouldn't really recommend this approach. So I'm moving just a little bit these eye dots, so YouTube will not consider this an adult content because of the horrors it can do. So let's solve the identity now. Select the body shape and hit Mesh to MetaHuman. This will send it to the online creator. In this old online creator, I want to select the Groom assets that I set for my original mesh back in 5.6 project. With a little bit of work, she can be easily Jason Voorhees with these eyes. Just for demonstration, I'm going to select the lashes as well, select the brow and get the exact same hair strands. And this is all I need. Now I can close it and it automatically saves it. In Quick Bridge, after quite hundreds of logins, you can reach My MetaHuman tab here. And we can go ahead and download it in high quality. Once it's done, you can add it to your project here. And now we have these Groom assets here as well. But we can't still export it just yet. For that, close this project and navigate to 5.5 project folder. Create a folder called Plugins, unzip the Groom exporter there, but we only need what it contains. So I move back the whole folder and just move what's inside. Then start your 5.5 project. Now you should see this little button here. To use it, select the Groom you want to export and press this button. And just like at the identity mesh, it saved it down to a project folder under the saved folder. And now you can see it's right here as an Alembic file. I will export the eyebrows and eyelashes as well. You can close this now. In the 5.6 project, I'm going to export the body with the same settings as the head. And I'm going to export the baked textures. Make sure you organize these properly. Now in the face, there are a bunch of LOD related textures as well, but obviously I'm not going to manipulate them right now. These are the ones that we need from the eyes and the LOD1 textures for the head and the teeth. Export them in a separate folder. In Blender, create a folder that will contain our finished meshes. Hide everything else, then import the FBX files. Hide the rigs, create a folder for the Grooms and import them as an ABC aka Alembic file. If you are in normal Blender scene, you might need to scale this again, which actually will cause issues regarding the radius, but it can be fixed. But as I recommend to use Unreal measurements, just in case. Organize these Grooms and continue importing them. Now back in 5.6 project, we still need some textures. Under MetaHuman in Common, go to Look Dev, Common, and Textures. And we can export all these three. Save it yet again in a different folder. Next, in Eye Textures, we can go ahead and export all these. I'm not going to integrate all of them, but it's easier. Again, save it in a different folder. Same with the iris. We need something from the skin as well. This micro skin one. Cavity is not necessary, but we can export it as well. We can export the wrinkle mask as well if we want to set that up. Get into the teeth textures and get these as well. And we will also need this micro tiling skin mask. And in the all, look for this T_underwear mask. And this was the final one. Now let's start the materials in Blender now. We can see that the head contains all the materials we need and some LOD ones as well that we don't need. Go to edit mode, hit F3 and look for separate by material. Now I did what it said, separated by material, but since it's from Unreal, you guessed it, something is not right. So we will have to select the right ones for each of them and rename the meshes logically. First is face skin baked LOD1 for the face obviously. Rename it and hide it. This is the teeth, look for the teeth material, rename and hide. For this look for hide 6. Name it, hide it. Eyelash to eyelash, rename and hide it. Get these ones and look for shell. Assign it, name it and hide it. For the left eye, look for the left eye. Right eye for the right eye. For these little ones, lassima and apply it. And for this, look for a simple hide. Now let's unhide everything. For the body, we only have one, so we can't go wrong with it. We can change the viewport display to white to be able to see something. Let's start with the obvious, the face. Open a shader one and let's change this to a material preview. Get 3 image textures. Now a quick explanation on what kind of textures we have here. So here the ones we see without folders are the ones that came with the FBX export when I checked bake the material inputs. You know, that mesh data bake. As I said, and as you can see, it did something, but not really much, as I said. It's mainly to demonstrate what it does. Next, we quickly look into the DCC exported ones. We have maps and source assets. In the source assets, there is shader maps and masks. This DCC export purpose would be to set up automatically the whole MetaHuman if we would be able to use the DNA files in Blender. But without Polyhive paid add-on, currently we are unable to do that. But we can utilize these textures from here. It creates things differently. For example, you can see that the wrinkle mask, for example, not combined into an RGBA textures. Instead, they are all separate black and white textures. Now the maps is much more interesting. We can see some familiar textures here, along with the eyelashes, face LOD normals, and exact wrinkle normals for this character. Underwear color for both body and chest. The chest, which is in this case means the head. Now let's look into the face textures we exported manually from our main textures. These textures represent the actual character we created, but for example, instead of cavity textures, we can see SMRF and SMR and some scatter textures, along with some grayscale iris as well, which allow us to have greater control over our material setup. More about the others later. Let's import the base color and plug it in. Get the normal, set it to non-color and plug it in. And you can immediately see that this is not right. And that's because Unreal uses DirectX normals and Blender uses OpenGL. There are a variety of different ways to flip the green channel, but I want to temporarily flip it to Blender only. So for that, get a separate vector node, get a combine vector node, get an invert color. Actually, the correct one is with a simple math and subtract by one node, but it's going to be just fine for now. And now we can see it's looking much more better. Let's drag this down and get this SRMF texture. This is an RGBA pegged texture, so it's specular, roughness, metallic, and the alpha is a peach fuzz map in this case. Get a separate node and plug them up like so. I'm going to talk about peach fuzz in the end of the video. We can get a simple color ramp if we want to tweak the value. Okay, image texture time. This time we get the scatter. This is responsible for the subsurface. Set the value here to 1. Depending on your scene settings, since mine is Unreal measurements, I need to delete a 0 here. You can see that without the texture, it affects the whole mesh. But when I plug this in to the scale, you can see that it now only affects certain parts. Get yet another texture. And this time go into the band folder and get the band normal. This actually contains the ambient occlusion map. Get a mix color, set it to multiply, set it to non-color, and get an alpha and plug it into the second socket. And as always, with the factor, you can tweak the strength of it. Let's leave it in the middle. Let's make some space. Get 2 image textures. You might think that we will need this right now, these 2. Well, nope, because these 2 textures belong to the tease material. Logical, right? So what we need instead is in the micro folder. This one we need skin micro tiling. Open it up and set it up as a non-color. And get the skin micro tiling, non-color again. Get a mix color, plug it into the A, and the micro tiling mask alpha to the factor. Set the B socket to pure white. Get a texture coordinate and the mapping. Connect it up like so. Get a bump node and connect it up like so. Change this to mix, so in the pegged texture, the alpha is responsible for the micro tiling in the face area. As you can see, if I remove it, it's going to be visible everywhere. Now we need to scale this up. Unreal use a scale 70 by 70, as I remember, but it can be totally personal preference as well. Now just set a low value to the distance like so, and the base of the face material is done like this. Let's make the easy ones fast. Go to the hide one and guess it, it's going to be hidden. So on both hide and hide 6, you can set the alpha to 0. Now next is lassimal fluid. Follow these steps. Go into the eyes textures this time. Now these textures are not character specific. It's a basic overall MetaHuman textures. But this is exactly what we need here. And this is the normal we need. Lassimal. Set it to non-color and get the normal flipper node from the face. Oh, and I forgot to add it here. Now back in the lassimal, add it and connect it up. And set a really low alpha like so. We can set it to blended as well. I set the eyes for white now and go to eye shells. Bring down the roughness and get a low alpha like so. And get an IR of 1.31. We can set it to blended and get value as well here and set it to a low value. We might change it to deterred later. Now, the eyelashes. Now, the only thing we can get out of the baked materials is the actual color of the eyelashes that we exported out with the FBX, but it's kind of pointless. Go to the DCC folder and get the eyelash color and make sure it's connected to the alpha. We can set it to non-color. For cycles, we can increase the transparency like so. We can bring up the metallic and lower the roughness. Now the teeth. It got one right, but I'm going to delete it. Image texture time, teeth base color, teeth normal, copy the Y inverter, get the SRM teeth, and separate it just like last time. Obviously, this doesn't have anything on the alpha. New image texture, but this time we get a teeth mask from the common textures. This contains the AO for the teeth on an RGB channel, so connect it from the color. From the common, grab the teeth sharp normal, non-color, add the Y inverter, and connect it to the bump, and reduce its value. Give it a subsurface and get the teeth scatter image from the base textures. We could go on and use those microtiles that I showed you earlier. Those are actually for the tongue, but in my opinion, it's a total overkill, unless you want to do some dental showcase. Now let's start the eyes. Let's hide these to see it more clearly. So the eyes are always kind of weird because Unreal Eyes material only relies heavily on texture manipulation, masks, and mass instead of actual geometry. In the past, they used the geometry method like we do in Blender, like there is a separate object for the eye parts, which is much more common and easier, but we will do our best to get the same result. But for perfect result, we still need to tweak it a little bit, but more on that soon. So I guess we start off with image textures. Get the texture coordinate and the mapping. We start off from the common eye pack, not our baked character textures. And we get this sclera. Turn down the roughness and the spec up. Get brightness and contrast, get a hue and saturation, and connect them up like so. Now we can tweak the strength of the veins with these two values. Now do some space, and now we will look for an iris texture. But which one? Let me show you the common one first. Get a mix node, get another mapping, plug it up like so. Just to show you, this is how it looks. And if we set the value to 3 and 3 on the X and the Y, we can see that it's quite good. Z doesn't matter, by the way, we are in 2D space. Now if you connect them up like so, we can immediately assume that we just need some sort of mask here to drive the vector. Luckily, we got something for that. For that, we need a mapping as well. Open the common pack and look for this iris one. And use this one, set it to non-color, connect it to the vector, and if you set a value of 1 and 1 on X and Y, we can see some progress. But it's kind of small, and that's not how it looks in Unreal. But we can manipulate this a bit, like so. So now it's kind of looking right. For comparison, you can see the difference. Now let me show you with the DCC eyes color. You can see that it is right from the get-go, but we can't manipulate it as we want to. However, we can manipulate this in the setup, but it would be easier if the iris doesn't have any color. You also have to understand that these separate texture packs, the DCC, the common and the basic textures, all basically bound to each other, especially the normals. You will see it in a second. So for the iris, let's get this texture. Make sure you use left and right logically, and also get the sclera from here as well. You can see that the character-based grayscale textures even contains the set it up eye variation, while the other ones do not. You can see even the sclera is different. Now we can manipulate the iris much better. We could able to use the exact color picker that Unreal have if we would want to. Let's clean up this a bit. So I'm left with the basic textures. You can also achieve the same results if you set these two and plug this into the location as well. Now as I found this version is still too big, and what is most accurate for the mask would be this setup. So my advice is to use this one, but it's totally up to you. Let's continue with the normal. From the base texture, get a left normal. For more clarity, we can name these so we don't get lost. Usual non-color and flip the axis. And you can see that the normal perfectly matching with the veins. If we would use different ones, then the veins would not match in the normal or in the base color. Get this normal as well. Plug them in like so. Get a mix color and use this as a mask, just like at the diffuse color. Now we need the tiling map, and this will be the common eyes. Flip the normal, get a bump, and set a really low number. Turn on subsurface. check it in cycles, seems okay. Now let's get this mask, non-color, and use this as a vector. To show you the difference between the two masks, this is how we can set up the limbal for the eyes. Get a mix color, get a subtract mask node, plug these just like me. And now we can manually control the limbar color. But some things are just a bit overkill for me, so I'm not going to use that, but obviously you can. But I'm going to place it up here just in case I want to. Now we can also create some Blender specific pupil movement as well. Create a base and one shape key and set it to 1. And go into edit mode, select the edge around the pupil like me. Select individual origins and select normal. Right click and use edge slide. Then rotate it roughly to the corresponding edges to avoid the rotation. And now we have some basic pupil movement. However, technically it's inside the rig, so there is a pupil bone here which controls the scale of the pupil in the engine. But we are not going to use that here, it's just way easier with shape keys. Now in edit mode, let's select the full iris, go to vertex paint and add a color attribute, name something like iris. Select this little edge, then paint it with white. In edit mode, invert the selection, then paint it with black. In edit mode, let's invert the selection once again, then duplicate this section, and with P, separate it. This will be the Blender specific iris. Make it its own material and call it iris left. Select the middle part and with the proportional editing, push it back. On the Y axis, just a little bit for now. In the original eye, let's make some space here and get a glass BSDF. Get the color attribute node with the iris vertex group and get a mix shader. Connect them up like so. In Eevee, make sure ray tracing is enabled. I just turn off fast GI for now. You don't have to, it doesn't really matter. Here in the material down below, make sure you tick in ray trace transmission. Get a value node and plug it in. Now the iris should have been revealed. Make sure only the main eye material have a ray trace transmission enabled. If the iris has it, you will see this. The iris should be fully rough. And now it's looking quite good. We can also reduce the IR level. Let's see it in cycles. And it seems nice. Now let's do the same thing on the other side. Just make sure you change the textures to the correct one. Otherwise, everything is the same. I don't get into technical details now, but don't duplicate or mirror the eye. Take your time and set up the other one manually. Now that both have been set it up, and if you are happy with it, you can move forward, but I want to manipulate it just a bit further to give that a nice bulge effect. So get the iris material, select the pupil, make sure normal is selected here. Then we will move the iris on the Z a little bit with proportional editing. Try to avoid to move the edge like I do. And now it's looking much more cooler. Same on the other side now. Now we have pupil and everything. Now it's looking awesome and identical. Now here comes the chest. Duplicate everything from the face and paste it. Remove the AO part and replace the images. The original body texture, same for spec, rough and metallic one. Subsurface on, get the scattered one as well. Normal as well. Now let's see what we have here. Micro tiling and micro normal. Let's see how it looks. You can see it's kind of weird. Now this tiling texture contains multiple information on different channels as masks. Let's get a separate color and see how this works. Use the red one as the factor instead of the alpha. We can increase the scale here for better results. Now it looks flawless. Now we can bring back the top if you would want to. This will help you understand everything else a bit more. So let's look into the folders and look the underwear mask. Get a mix color, set this to non-color, connect it up like so. Get a separate color, let's check each. Red is for the body top, green is for the shorts. Now the blue is for the face area's top part. We can even simply change the color if we only want to do that. Now about the normal. So this normal is containing the underwear normal as well. But actually I will want the normal without it. In the DCC textures, we can see a chest normal and chest base color, underwear normal and color and a lot of things. First, let's check the simple body normal. You can see that this version does not contain the underwear normal, which is what I will need. But if you zoom in, you can see that the normal contains skin information in the area, so it's not a blank normal in this area. It's also good to notice that the micro tiling is also stops at the underwear due to the mask. Now it might not bother you, and you can simply not use that function, but I will fix that as well. Go to the DCC textures, and as I said earlier, the chest in this case means the face area. and the body is the body. Don't confuse yourself with it. So we want this body underwear color. If we plug it in, we can see that this is indeed a color, but it needs a mask to tell which parts should be colored this way. Now here, if I plug this into the red, you can see that the top becomes visible, but there is no normal yet. Get that normal, flip it as usual, get a mix color, plug it in like so, and get this as a factor. Now we can see that we actually have normals on the top now. So we got back all that info. Now here in the microtiling, we got some problem. So quickly fix that by adding a green and red channel together with a mask add node. Now it's all good. Now in the face, basically it's the same thing, but with the chest color. Let's copy these and use the blue one now as a mask. I actually used the wrong, so chest underwear color is needed, and now it's all good. Now we can see again that there is a tile problem. So solve it with a math again. And this is how you get back all those infos. However, this was just an insight because now I will start modifying these textures. I delete all these extra top related ones. And just to verify, I'm using the DCC texture body normal, the one without the underwear normal. Okay, let's duplicate the mesh. This will be the sculpt mesh. Clear all transforms and remove the bone. Now let's turn them to quads and turn up these just to get better results on the Multires. Now I add the Multires, there will be a splitting issue. Just to show you, I'm going to add some. So as you can see, we need to merge them by distance. Depending on your scene, you might need to change that value. Check it all around if there is any gap. If there is none, we can continue subdividing. Before we start the sculpting, we should go to UV and select all this and move it on the X by -1. Now it's exactly in the first tile. Now we can go ahead and start sculpting. I want some simple panty. I don't go overboard with it, just a really simple one. And I'm also going to add some extra skin details on the cheeks and in some other areas. Once we are done, let's go and bake this. Get an image, make it 8K, possibly to match our main normal map. Non-color and bake it. Now we get the details. Nice. Let's check it in material preview. Seems good as well. Save the image down in a separate folder. Make it 16-bit. Now let's use the normal combiner add-on for this task, which you can download for free. Or the more advanced version, which is not yet implemented to an add-on. It's currently a simple blend project file that is much more powerful, and I will show you that in this video because we are going to need that. So once we've done that, we have a combined normal map. As you can see, it successfully combined the two normals. Next, just to show you, I'm going to unplug everything except the normal and show you that the problem with the old combiner is that I did what it should, but those skin details are still there. Now the easiest you might think is just to simply paint it in texture paint. But depending on the complexity you did, it can be problematic in places like this, and you can't really get rid of them in these small places like this, like here. But don't worry, we are going to fix that as well. So this is one of the reasons I wanted to upgrade the normal combiner add-on. But currently we will move on with our task since there is still a long road ahead. I make some space here and connect this up like so we can see the microtiling mask. Actually, what you can do to blend it way better is if you set the average normal map color here instead of white, so it's not that harsh transition. But I'm going to set it back for better visibility now. Now we need to manipulate the textures and the red mask somehow. For demonstration, I'm going to create a texture, set the alpha to 0, and I'm going to leave it on 1K. Here I make sure that the right texture is selected, and in RGB I select only the red channel and start painting some. Now I'm going to create an 8K one with the same method. Get the texture and paint it. So you can see immediately there is a huge difference here. Like the texture size matters. I know the reason I'm showing you this, that you can make high resolution detail with bigger, better maps, because I'm going to do it with 1K, just like the original one. And it's not going to be as pleasant as a high res map, but for me it doesn't matter because the panty will not be visible for me. And this is just a way to save some time. So shortly, you can see that the original mask is low resolution too, and that's because Unreal only use this for micro details. If we would do that, 1K is totally okay for us, but I'm going to use this mask later on the normals as well. And that's where I will save time. You will understand it soon. Now we need to remove this value from here, so only our panty is masked out. We'll maintain all the other values for flexibility on the green and the blue channel, and not forget about the alpha as well for the full face microtiling. Unplug this now and move it up here. Get an image texture, and I'm going to create that 1K texture I talked about. set the color to full red with alpha, open this up here, and save it down in a different folder. Get a diffuse BSDF, connect this up, separate color, combine color, and connect it up like so. Get a vector math and set it to subtract. Get the red, plug it here, this to the second socket and this to the red. Get into texture paint, single image and select our texture. Let's unconnect these so we can only see the red. One viewport to solid, one viewport to material preview. If you want to manipulate the others, you can do the same exact thing for them as well. Get these normals so we can see what we are doing. And with add alpha, ironically, we can go and remove the unneeded red value. I'm going to speed that up. Okay, that's done. Let's save this. And I'm actually just paint these parts with simple mix. And remove any accidental brush strokes with erase alpha. Save it. Now connect all up, and now the red is exactly what I wanted. I will duplicate the character. You can actually just create a new UV map here. So you not necessarily have to duplicate it. It's just more clear for me. Now modify the UV like last time. Get a new image, and this will be the one we will bake the new setup. Alpha to 0. Build alpha digged in, select diffuse, uncheck these and hit bake. Now cool, but we are not finished with it yet. First save it down and I will show you why. So these are looking cool, however we lost the alpha texture. So we need to get that back. There are easier ways for this, but as I said it's purely a free version tutorial, so let's do this in Blender. Go to the composite, check in nodes, unplug this and get a viewer. 2 image nodes, get the saved down new mask, connect it up like so. We can scale the backdrop to see the whole picture. Now get the original mask texture, get a set alpha, set both to non-color, connect the new mask to the image, get the alpha of the original mask and plug it in to the alpha. Now these settings can change the outcome of our texture as well as how we save down the new texture. So if something goes wrong, it's definitely that. For this, I'm going to set it to replace alpha. Under color management, we have to set the view transform to raw. Up here, we can cycle through each channel for preview. Under node section, we can see this save this image if I click on the viewer node, but only if the viewer node selected. Save this image now. Don't worry if it pops off, it's still there. You just have to switch back. Now here in the layout, let's switch this back to AGX, open the new image and compare the two. It's not quite the same, so I go back, set it back to raw and set the option here to JPU and full. We can connect this one as well, then save it again. If the red is still too harsh, we can do a separate color by channel and get a combine color and just remove some of it with a subtract node. So this way we will get rid of those artifacts. Save it again and check it. Now it's finally looking good. Switch this back and check. Compare. We can further tweak this, but it's perfectly fine like this, but just in case, check it on the face as well. Seems good, the main parts are still perfectly there. I do some cleanup now, frame and name some nodes, and connect everything back up. Now other than the diffuse, we will have to modify the scatter and the packed spec rough map as well. But other than that, it looks good. Change this to avoid that harsh edge, to compare this what we did with the new micro mask. There's also the underwear mask that we can change. However, it's much more easier since that is just an RGB texture. There is no embedded alpha here. So get back to our baking section, bring that mask and connect it up like so. Or we can do it with an emission as well for more accuracy. We just need to modify the green value. New image with alpha and without alpha tick. 1K, save down an image as a non-color, get a mix color and plug it in like so. I change this back to diffuse, plug in the normal here, go to texture paint, and so I can see something, I plug in some random color map here. Then paint again, now with full green. Okay, it's done, I connect it up and bake it down to a new image. Alpha is not needed, save down the image as a non-color. We can set this raw just in case, and finally I'm going to bake it on emission. Once that's done, we can save it down, change back to AGX, move this bake section away, get a mix color here, separate color, get the green, plug it into the factor, main normal to the A socket, and to the B socket we can set the normal color. If I bring back the original normal, we can see it successfully removed that area. You might want this method since you might already created some normal variation for the surface of the panty and you don't want to overcomplicate it, or maybe you just want to do a solid color change. Get a duplicate of this new underwear mask, plug it in, and now we can color this area with ease. But I want to remove that gray area now, so I go into texture paint, get the base color, and with the simple clone tool, I'm going to modify the whole section. Do this in a flat viewport shading. Now it starts looking much more pleasing. Now go ahead and make sure you save as your new modified texture just in case. So the point is to not overwrite your already existing texture. I also forgot that I want some black nails, so I'm going to do that now. And save it again. And we might need a color map for this. But right now it's just solid black. So let's change this to some actual material. I'm going to create a new folder and look for some black cotton fabric kind of thing. And apply to a simple cube, for example this. And now let's build that material into our material. Copy this diffuse. Get a mapping and set a higher value like so, depending on your texture you picked. Make sure you remember what you set here. Adjust the color map if needed. Connect this up to the diffuse. On the material output, get an image. On the new image, set the alpha to 0 with the ticked in alpha. Change this to diffuse and bake down this new base color. Cool, it did what it should. Check it. Save it. Now we can replace this whole thing with the new image. Now let's delete all the unnecessary stuff, frame stuff, and organize things. In Texture Paint, we can further tweak this new image. I'm just going to paint a solid purple here. Okay, cool. We will need to integrate that normal to the maps as well. That's why I said don't forget the mapping size. But before that, let's do the others. Start with the easiest, the scatter map. Get a mix color, plug these like so. Get an invert color, adjust the color map if needed. Adjust the white value to match the original. Yes, that's a cheap way, but it's working. Plug to diffuse. And yet again, we are going to bake it down to a new image. Save it as a non-color, hit bake, check it, save it. Label this and put it somewhere. Now we can plug it back in. Okay, now the specular and rough map. Get these and set it back here. Image texture, alpha to 0, with alpha ticked in. This will be our rough fix. Create a new folder for this and save it down as a non-color. New image, same thing, this will be our spec fix. For metallic, we don't need any since we don't have any value on there. Get a diffuse BSDF, add the mix color. Get a diffuse BSDF for this one as well. Get an alpha and plug it in into the factor. And add the separate color just before here. Now Texture Paint mode, select the rough fix. You can select a grayish color and we can see it's already working. Also get the normal so we can see what we are doing. We could simply paint it with this, but I want to be blended way better than this. So here, let's add the texture. Here I select noise. Under here, change this. And play with the values until it fits. This seems almost good. Still too harsh, lower it. Okay, now that seems very good now. Now I'm going to speed this up. Okay, it's done. Let's save this. Now connect the red one and change this to spec fix. Select the spec texture. Clouds seems the most fitting. Set this to tile and change the scale. And paint it. Okay, save it. We can further give this some noise as well since the original spec has that. Okay, cool, save it again. Now let's combine it. We are going to use this bake section up here, but a little differently. Let's copy paste it. But get a mix color and set it to vector. Set it to non-uniform. Get the base SMRF map, plug it in, and plug this up like so. Get the spec fix and plug it into the A socket, and the alpha to the factor. Get an invert color right here, copy this and paste it. Get the rough fix and plug them up just like me. We can get emission maybe instead, and compare it. Get an image texture on which we will bake it, set it up like so, save it down and let's bake it. Save it. Get a separate color and a diffuse map. Compare the results. Now again the alpha. Now let's get to the new mask here, plug this here. Get the old one, plug this here. Zoom out, but this time set the apply mask instead. View transform to raw and save it down as our new SMRF map. Change this back to AGX. Get the new texture and check if everything is alright. Red, green, blue channel, and check the alpha as well. Seems it's worked just fine. Let's again go and organize and clean up things. So now we have the final diffuse, the final scatter, and the final SMRF map as well. The only thing we need to finalize is the normal for the panty. I want to get that normal into the panty, but only on that section. Now for that, I'm going to save down this image, but now I can see that I will probably going to use another material because that normal is really low quality. Anyway, let's move on. Now it's time for the premiere of the new updated normal combiner. Currently it's only a project file, but it will turn into an add-on hopefully soon, and you can grab it in the description below. So when you open the project, this is what you will see. I updated quite a lot of things here, now with new useful functionalities. Let's go through all of them. So this was the original input for the normal combiner and the base extra normal map. We can still use the base functionality, it's still there. And that's the basic setup when you open it up. The strength as well is still there, but up here I created a masking system to combine only specific parts of the normal that allows you to utilize a texture-based mask with all 4 channels supported. And I created basically a switch here, and I write some comments on this as well to be more understandable. So if it's on 0, the mask functionality is turned off. If it's on 1, then it is on. Also, I now added a strength slider for the base normal as well, and not just for the extra normal map. You don't have to bother with anything else here. Back here we have an additional switch. This switches between basic normal combiner logic and flat combiner logic when it's set to 1. But this means if it's set to 1, then it uses this flat normal as an extra normal map. And then you can mask out parts of your base normal map through texture-based mask, again with all 4 channels supported. Now here there is another switch / functionality. This allows you to simply convert OpenGL to DirectX or back and forth. Right here, this is the value that determines whatever the change should happen. So when you input the texture, you see your original version. When you set this to 1, you will see the flipped green channel version. Now let's see this in action. First, let's turn on the flat normal combiner, get our base normal map, set it to non-color, get the underwear mask, set it to non-color, and let's turn on the red mask. And now we can see that it is indeed masked out that area. Let's see the green as well. It's working, let's turn off the red one. Super, that's done. Now let's change the resolution if necessary, but currently it's on 8K, so it's perfectly fine for me. And I just hit render image. And now we have a new normal map, so we can save it down as a 16-bit. We can exit this. Now let's turn this off, and let's just use the base normal combiner function and get the panty normal I sculpted in the Multires and set it to non-color. And you can see if we would use the original base normal, the normal combiner would do what it should and combines the 2 normals. But I want this specific area to be flat. So let's change this to the newly baked flattened normal I just saved down. And now we can see we totally smoothed out that area. And only our panty normal is visible here. But we want to go further, so we will use the functionality which masking the normal combiner. I turn this on by setting it to 1. That will remove everything from the base normal, since there is no mask texture input added yet and we didn't set any value. So here let's add our mask. Again, we are going to get the underwear mask and set back the green value to 1. Now we can see that it's a bit washed out. If I turn the mask functionality off, we can see it more clearly. It's not because of the function, but because of the mask I created itself is washed out. It needs some color correction, so I'm going to fix that. But currently I don't need a masked out version of the combiner. I just need to use the original functionality since I created the details on the cheeks as well. And I want that on the normal map. So let's render this out and save it again as a 16-bit non-color texture. Just to show you the current difference, I'm going to hop back to our project and you can see there is no longer skin data anywhere on the panty. And back here we can see my added extra skin details as well. Now let's add that final detail to the panty now. In the combiner again, for base normal, let's select the normal that we last saved down. And for the extra normal, select the new black cotton material. And by the way, that's what I said, that I will need to change this normal to something different, but I just go with this for now. Now you can see we are in a simple normal combiner mode. The normals would, as you guessed, get combined. And now everywhere on the body would be this cotton fabric normal. And that's why we need the mask, because we want it in a specific area. Now let's turn this to 1, and we can see that it does exactly what it should. Now this is not in the function, but I will include this in the final project and in the add-on when it's ready. So I just add here a mapping and set the exact value I used at the diffuse. That's some really bad normal, but we could render it if we would like to. But I'm going to look for a better one now. Okay, found one. So here I can even show you the last functionality, the OpenGL and DirectX switcher. Turn this to 1, and down here select the normal we want to switch. Change the texture resolution and switch this to 1. Render it out, save it down. And I just turn off this and use the new normal as an extra normal map. Adjust the mapping, adjust the resolution, make it and save it. And let's test it. And now we have a fully custom normal for the body. Let's go ahead and plug everything back in. And this is what I said about the masking and the resolution. Since in my character it won't be visible, I use the low quality mask, and that's why those hard edges are visible. If you want crisp results, just pump up the resolution. Okay, so the body is finally done. I'm going to create my own makeups now. It's basically exactly the same process. So I'm going to jump cut that and show you the results. But in my Raven character, I'm going to show you some makeup tutorial in the upcoming weeks. So this is the first version, the thinner one, and there is a thicker one with some different shading and colors. Now let's jump to the Grooms. I still have the head identity here, so I'm going to use that as a base, select all the Grooms and parrot them to the head as an object, and move it and match it as close as possible. It shouldn't have a very big difference. Okay, now I can hide it and leave it here in case I want to change something on the head later on. Now let's check the Grooms. Seems okay, so let's clear and keep transform and apply all transforms. And make sure the origin is dead at the center of the word grid. Now I'm not going to bother with the eyelashes, so I hide it. First thing you need to do is to go to the hair curves tab. There are various attributes here, and these are extremely important, and we are get back to them each one by one. Most importantly, set your surface, which in this case the face obviously, and set its UV map. Do this to all of the hair parts and for the eyebrows as well. I would like to mention that the strand-based hair is a really delicate thing, messy and confusing. So keep a close eye on everything, because one wrong move can ruin or break the whole strand system. Do not modify anything in edit mode, just in scope mode. Up here at the curves, hit this snap to nearest surface. This will create us a necessary attribute, which is the surface UV coordinate. It also does what it says, snapping it to the surface. If you would use the other one, that will cause troubles. As you can see, some of them not attached. That would cause hairs on the floor effect. This is usually used when you create a hair from scratch. Let's undo this. And let me show you, if you don't have a surface connection, you won't be able to manipulate the hair fully. So this step is a must and important. Snap to the nearest surface both. Let's add some random material to this and see what we have. Well, in Eevee it looks great. How about cycles? Well, she's kind of baldy, and that's because various reasons, but mainly because of the radius. And we will fix that. If you had scaled down your hair way too much, for example, you started your project in Blender settings, you might see a very thin hair strands, almost translucent. But the radius can fix that as well. More on that later. First, I want to use this slide brush, since her hair is split in a different place than this. Now, these follow-ups are really important as well. You have to constantly change this according what do you want to do to make your life easier and to avoid distorting the hair. So here, instead of custom, since I definitely don't want custom movement at the roots, I'm going to set this to root and projected even. And very gently move them and align according to my reference. Place and put them in a small portions if needed. Try to close the gap, but it's depending on your hairstyle. I also want to delete these flyaways here, so I just use this brush for that. Okay, now let's comb it. Again, experience with the fall-offs because it's really, really important. I want to change the length of the hair as well, since hers is way longer. Make sure the fall-off is on root. Comb it again in a way it's slightly bent on her breasts. Try to avoid any clipping. Now let's add some new strands as well. When adding new strands, these options can really help you out under interpolate. So you're probably familiar with this term, but in basic terms, it will copy these attributes from the nearest point. So in my case, I exactly want these three. I want the length to be copied, the radius, and the control points, but not the shape, because I want to comb it in my way. If I add it like this, you can see they are aligned simply with the normals. But if I check in shape, you can see it copies the shape as well. But I don't want that since it can result like this. So I'm going to undo that and redo it without shape. We can pre-select this whole thing, which I will show you later, but if you didn't, just like me, we can still mask it out. In the selection tool here, we have two options to pick. One is curve. This means it will select the whole curve in length, which is exactly what we need right now. You have to hold shift to be able to paint more on this exact mask. And now I can freely comb only this section without interfering the other strands. But be aware not to go into the head since there is nothing that blocks it from clipping. I'm going to delete these in a sec since it interpolated some flyaways as well, which I don't need. Now here under select we can hit select all, and now we can manipulate the whole hair again. I'm going to delete these and comb the whole hair to blend it together. And I'm going to add a few more to the other side. And again in selection mode, curve, and comb it in a way to cover the face more, giving this hair a much more dense appeal and closer to the reference. These flyaways, man. Comb it carefully and softly. I'm going to slide this a bit more up here as well, so it's not that high up. Pull them closer. Now I'm going to use and show you the point selection as well. This allows us to select portions of the curve, as you guessed it, in points. I want constant selection, so I change the fall off, because I want to make sure everything is selected. And up here, now I'm going to invert the mask selection. This will help me make sure that the roots will stay intact. Now I can use a custom brush as well to refine the combing. I can use some smooth on the hair and keep refine if needed. Let me just change the color a bit, the metallic and the rough. Now let's hit in cycles. Really boldy, so let's fix that radius now. Add the modifier named Set Hair Curves Profile, and we can immediately see the difference. You can see this is Dig In Replace Radius. It's important to fix, besides the obvious reason, it will help us make sure that the added extra strands will share the same radius as well. So now it's only a matter of setting up the radius that fits for your hairstyle. On the other side, if you have visual issues here, even after radius, you should go here down below under curves. There are some options we can tweak. In the viewport, it can be strands or strips. We can add and should add subdivision as well. If there is none, this is how it would look. And strip also can cause different look. So let's experiment with the radius a bit. Again, this value also highly depends on your scene settings. Her hair is quite thick, so I'm going with that. But before that, I'm going to fix that bald spot right here. And just pull these hair strands. And refine it a bit more. Let's check. Okay, now that bald spot is no longer. I'm going to use the same settings on the back of the hair as well. So let's apply it. Now let's do the back of the hair root projected and let's grow the hair. Some comb, some sliding, and adding some extra and so on. Now I just add the same modifier. Check it. Seems good. We can always change the radius profile if we are adding a new modifier, by the way. This radius, and we can also further tweak it in Unreal if we want to. Now that the radius attribute is fixed, let's test and see what else we need. For test, let's add a clump, and we can immediately see that something is off on both of the hairs. To fix that, we need to create a curve index map. Move it to the first, and we can see that it basically solved our issue. However, we have to look closely and find any single strands that doesn't obeyed this modifier, like this one right here. The guide curve index is making sure each strand stick to the correct guide curve. In simple terms, it's physics related. Let's add it here as well. And we can see that it's also have about 2 strands that needs to be deleted. Depending on your scene, you might need to change that. Now here at the output attributes, we can select the guide curve index. Go to sculpt and with strand selection select it, then delete it. Apply it, and now if we want to add some clump, it should work as it should. Now fix that one little strand back here as well. Sometimes it's quite hard to select it. Okay, I finally got it. Delete it. And add the output attribute and apply it. Test it with clump. Now there is a useful stuff here also, duplicate curves. 10 is way too much in this case. However, this can significantly increase the render times, but maybe this is something you are looking for. But I'm not needing that, so I'm going to remove it. Okay, let's move on to the eyebrows. Let's align this properly and apply all transforms. Snap it to the surface, and if the snap is too deep, don't worry, it's still there, just push it out with comb carefully. And now we can start modifying this one as well. Give some material. This little icon actually should be preventing the strands to go inside the mesh, but I don't think that's working. Maybe I just don't understand this function. The eyebrow should be handled really gently, so make sure when you're sliding it to make really small movements and align it at every step. Use the already showed tricks for masking, moving and combing, or interpolating. Always watch out for the fall off, it's really important. Her eyebrows kind of have a break in it, so I try to mimic that. Fix the radius, like at the hair, and check what fits for your needs. Trim hair curve modifier can also come handy in here. Keep refining until it looks good. Let's check with the hair. Check with different shading. I'm going to comb this hair part a bit. It seems jagged. Now it seems quite good. Now about the eyelashes, so I wouldn't necessarily see the point of doing all this, since it's way easier to create it from scratch or just simply duplicate the hair cards, scale them by the normal. We can even duplicate it one more time. Or simply in the shader, duplicate the alpha, get the texture coordinate and the mapping, get the mix color, connect it up, and go to add. And change this location a bit. So it's much more dense looking now. And now you can actually bring this simple static mesh back to Unreal, and on the eyelashes simply force LOD1, so it will be always these new hair cards. Now about the actual hair shading, get the curve info. Just to show you here, the intercept is responsible for the regrowth of the hair. I use a mix color here and use it as a factor for demonstration. And you can see if we do something like this, it's looking way more natural. Now the best version obviously is the principled hair and the melanin version. But we can only use this hair principled in cycles. This is the most accurate one. The melanin is self-explanatory, so if it has a low melanin, we are going to get a blonde or a full white hair. If it's on 1, it's full black. Redness, again, self-explanatory, but we can do some interesting stuff like this one here. And tint it up like so. The melanin version has 2 separate versions as well. This Huang one is much more accurate, but this one is good as well. I'm going to show you a bit more in a second, but we need to keep an eye on the attributes as well. So we still have that curve type attribute. So if I get that attribute here and plug it into the factor, you can see that the added hair and the original hair has different curve types. Now it won't cause huge issues, but they might look off in Unreal. You can fix that. Go to geometry nodes and add the new one. And just look for this node. You can see that this uniforms all the curves types to a single one. Now these types change how the curves are shaped. For hair bezier is usually the best because it gives a smooth natural strands and works well, but as I said, it doesn't going to have a huge effect. So I'm going to skip this now. I just wanted to make sure you got this info as well. Now on the other hand, we still have some must-have attributes. So click on this icon and you will see color here. Add it here as well, and here as well. Let's check the Groom exporter that I showed you. So this is the add-on you must see. You can actually see we need roughness as well. So let's add them. It can be point and float. Add it to the others as well. And now we would be able to export this asset now. And basically this is how you customize an existing hair. Now when I created the eye makeup, I created my cloth assets and built a custom hair from scratch. So first let me show you the first outfit. So it's a pretty simple setup divided into 4 parts: the top and the tie, pants, shoes and accessories. It's important that I didn't rig them, they doesn't have any weight paint data. I also created some extremely basic bra, but that's part of the chest set. So this is the first one, and here's the second one, and there's the second one. You can see nothing fancy here. However, I created these shoelaces. And this is the hair I created. It has 4 parts. This also demonstrates that you can build a hair from scratch in Blender and use it in Unreal if you want to. Now the naming should give us the ID, so the order of the hairs. This should determine how I see them in Unreal, but that doesn't really work for me. But anyway, I'm going to name them logically. Now I give roughness to all of it, and most important one is the color. And on this hair, I'm going to show you how you can create a fully custom hair color, since the other one doesn't need any hair color variation other than the growth. So let's show you the logic first. Here in the shader, I'm going to connect these up, sample this hair color, and what we will need here, that's right, a mask. But as an attribute. You might think we will do something with the color. Well, you are wrong. Well, sort of. We need to create a custom color attribute. Select color here and name, for example, color 1. Do the same on all the hairs that belong to the same groom. Now we can expose that attribute here with this node. If I plug it into the factor, you can see that the B socket is activated. If I get a separate color, same thing will happen on every 4th channel. Now I will leave it on red and I will get into sculpt mode. With the point select, I'm going to select a small portion here. You can see that in edit mode, it mimics this exact selection. That's really useful for us. But first, let's select all the curves, and up here, select set attribute. And at the color, set it to full black with alpha, then hit enter or hover off it. Now we can see that the A socket is activated here. Now let's select some part here with curve selection. Always make sure that color 1 is selected. Hit set attribute. And at the usual RGB channel, I'm going to use a full red value with alpha. Now immediately we can see that now the B socket is activated on the red mask area. And nothing is on the other channels. Now let's do another one. The green one now. Let's do the blue one as well. I will duplicate this 2 times and plug it in like so. And you can see that we actually successfully made all 3 channels. Now on the other ones, depending on what you want, you can set up the same thing and make it as colorful as you want to. But actually I only want them to have the black value, so I want them all to be blonde, so I'm going to set it up like so. Just to show you, I add some here to verify it's indeed working with any mask. But as I said, I don't need it, so I will just remove it. You can see it's working in cycles as well. And we can store and export this data with the groom in that attribute. Then we can and will expose it in Unreal as well. But since I only need a few pinkish strands, I'm going to remove that now. If you set it all to black, you can easily remove all masks. I'm going to actually fix something here since it slipped my attention, so I need some hair curves here as well to make it more realistic, but also this is where the pinkish strands should be placed, so I must add these. I deselect everything, then start adding some to the side. So therefore it's only one selected. For shrinking, I can use some fully custom fall off brush here, so they are not even, and comb it to blend it in. I can also maybe use to blend it even further with rotate hair curve node. Okay, it's done. Now I'm going to set the attribute to red on this. And I'm even going to add some density, and this time I want to mimic the shape as well, so I want a full interpolate on this area to make it more dense. Let's change the color also, comb it, smooth it, set attribute again to red, remove the unneeded selection, go ahead, invert selection and select full black. Invert it back and I do this until I get strands that I want. Okay, it's done. Check it in cycles. Seems good. Now let's see that with actual hair shader. So I jump cut and this is the set it up one. I use the mix shader to combine the 2 hair shaders, and the mask is the factor that separates them. This way you can fully modify both the roughness, redness on everything easily, all at once. Now here at the curve info I use the usual intercept and the random value through a simple add node. Random value can serve as a salt and pepper basically, and factored into a blonde and a black color, and should be connected to the tint. If you hover over the options of the roughness and everything, it clearly wrote down basically what you should set up on each occasion. The color here has 0 melanin and redness, so the tint aka the mask shines through fully. And you can see that the salt and pepper blonde back randomness per strand as well. I also now use a simple hair shader for the eyebrows as well. So this is what it looks like. Now it's time to export the grooms and outfits to Unreal. This is the first version, so if you open the Groom exporter, you should select all the hairs with Shift, which belong on the same groom. Since we have every attribute we need, we can easily do the export now. Drop down this, select surface coordinate here, get the color, roughness, and the radius. Same here. We don't need to set up these, although we can if you would want to. And just hit export here. There is only one value here, and if you are in Blender measurement, you should leave it on like so. But since mine is in Unreal measurement, as it should, I can write in scale 1. Then hit export. Same thing for the eyebrows, but always make sure origin is at the word grid center. We can export the new eyelash cards as well if we want to. It has all the necessary vertex groups for this head, so we can force LOD1 on the character. Now for the colored hair, set up everything as I did before, but at the color, I select the color 1 attribute. And I have to do this on all of the 4 parts and export it. Now for the cloth assets, the only thing you have to make sure that they are all scaled 1 and their origin is at the word grid center. If not, just apply all transforms. They don't need to be attached or weight painted to the rig, it can be, but in my case, it's way easier to do it in Unreal. Then export them out as a simple FBX. I have 4 major parts here, but I'm going to separate it to 5 because of the tie. And that's the only thing you need for resizable outfits. Now in Unreal, let's create a folder for outfits and grooms. And for example, for the cloth, if you have multiple assets in one FBX and you not check this in, it's going to separate it one by one. But I want all this to be one mesh, so I delete it and tick in combine static meshes. Now they are all together. Just organize them to different folders and so on. And once I imported and set up all of the materials to this, let's hide everything here in the middle. For quick check, we can drop every cloth asset in the scene and our character. Then in the details, just reset the location on all of it. Seems they are all fitting. Now we might bump into troubles with the resizing if you use the custom skeleton. It can work, but I'm going to show you the exact template meshes you should create clothing for if you truly want to create a precise and resizable outfits. So the engine at the plugin, we are going to look for MetaHuman creator content. This is where all the juicy stuff is actually. What we mainly look for will be under optional. There is a lot of cool stuff here. You can see all the textures that move behind the scene and a lot of interesting stuff really. But now we are looking for a default garment. And source body. We have these skeletal meshes for different shapes. And also here we have different body types for B, C, D. And you would want to build or modify your existing asset on top of these shapes actually to make it fully compatible with any character. Or you can just type in here combine body and grab one of them. Other than that, the full workflow will be exactly what I will do. Right click, create a skeletal mesh out of it, use an existing skeletal mesh, and here we should select preferably a combined mesh. But I didn't export out the new combined mesh that I modified, only the chubby one. So I'm going to use the simple body mesh, then hit convert. Open it up and go to edit weights. Down here, select the body from which we created the skeletal mesh for this asset. Then simply hit transfer weights. And if we scramble through the bones, we can see it's already done. And it's actually doing a pretty good job, so we can leave it like this. Then hit accept. You can test it as well, just in case. Now look for and create a cloth asset. Open it up, we can delete everything, get a cloth asset terminal, a skeletal mesh import, select the skeletal mesh we created, save it and close it. Right click, look for an outfit asset and hit resizable outfit. Open it up, tick this in, then add here the cloth asset and here the skeletal mesh we used. Right click again and create a wardrobe item. Open it up, look for the outfit asset. And at the pipeline, there is various pipeline setups, and we can see that the Groom pipeline as well, which I will use in a few. But here we need to select a MetaHuman pipeline. And here as well. You can always peek into the folder for some infos. Now these could be set it up if you would have created some changeable material instances, but I don't have any, so I will leave that out. And that's it, you have to do this on all of your cloth assets. Now that I created on all of it, the only thing I will have to do now is to drag and drop them into the MetaHuman creator. But let's see the grooms, import them. That's what you should see, the attributes with green and a few attributes listed like so. Let's hit import. We can see I have all 4 in one, as I said. Wait a bit till it loads up, then we can already see the preview here, which means it probably worked fine. Let's open the above. Seems good. Drag and drop the head into the scene, reset its location, and I will drag and drop the grooms as well, just to make sure everything works fine. Seems good as well here. Let's create a groom binding for all of them now. Select the skeletal mesh asset we need, which is our head. Now this option is not necessary at all in this case, but it doesn't hurt the process either, so I just select the head mesh again here. We can save this and close it. Do this on all of the grooms. Let's start setting up the modified one first. In the LOD section, there is currently only the highest available as strand, but don't confuse yourself since the hair is built from 2 parts. That's why I have 2 separate sections here. Now the strand is a much more interesting place to be, but make sure the binding here has the assigned binding we created, just in case. There is also physics here, which we will need to set up, but for that we are going to cheat again and get into the content folder for the MetaHuman stuff. And here we can find the eyebrows, hairs, and everything. And this is what I made out my hair of. So these are the settings I will going to copy. Since the hair can totally follow this one in basically every aspect, both material and physics-wise. But obviously we can set up a custom values here as well. For example, the hair width I want it to be different and a bit thicker. Otherwise, let's just copy these. Our 3 materials, the MI hair, MI hair cards, and the helmet. We can copy the names of the slots, select it here. I will set up the other part of the hair too. Next we will bump into a problem if you would want to generate hair cards with this plugin. Since in Unreal 5.6 it's basically not working. There is a lot of dependency issues regarding Python and there seems to be no way to fix it. I tried to fix it for hours, but it's pointless. So we will cheat this as well in a second. But before that, let's copy the physics. So enable it and basically literally just copy everything here. Copy the curves like so and paste them. What really makes difference is the collision actually. So we can see a huge difference here, especially at the radius. If you don't fix these, the hair will be clipping through the head in a lot of places. So make sure you do it right. We can actually copy the whole section as well, which I will show you in a second. But first time it's better to do it manually. Now look for the eyebrow. This time we obviously don't need physics, but I want to copy the material slots since there is nothing fancy about the eyebrows. Copy the slot names. At strands, change the material. You can actually customize these even after the item is in the MetaHuman creator. For the custom hair, I will going to set up a custom material as well. Or you can rework the Unreal hair material as well if you want to. But I'm going to create a material from scratch to this one to show you how it's done. Place it in the scene and let's create a new material. Open it up and change this to hair. Get 2 color constraints. I set them to red and blue for now. Get a hair attribute node. This contains all the attributes we have on the hair. Get an add node and the noise one. A lerp, a multiply, and a simple constraint. Right click and convert it to a parameter. Name it noise. Connect this up just like me. And set a low value like 0.1. Get another constraint, convert it to a parameter, and name it roughness. Set a value like so, and plug it in. Get a lerp node, plug it in like so. From the length, get a multiply node, get a constraint, convert it, and call it length. Plug it into the B socket, get a cheap contrast from that, get another constraint, convert it, call it contrast. Plug it into the alpha here. Save it down. Right-click on the material, create a material instance, then add it to your hair. Rename the slot, then add it here. I will modify these values. And this is how you can copy the full setup. Open up the material instance. We can see the exposed values here. In matter of fact, I want to convert this to a parameter as well. Call this blue one root and this red the base color. Save it, place the instance beside the viewport, tick in all these, and if I start adding some value to the length, we can see it's working like the intercept in Blender. The noise is not necessary, but I will need to adjust it since it's way too big right now. We can play with the contrast as well for more lighter or harsher effect. But now let's create the mask. So get a color constraint here. I will set it to green. Get a subtract. From that get a multiply. From that an add node. And finally a alert node. Plug this into the A. This one to the B. And the base color here to the B. Get a constraint, convert it to a parameter, and call it dye. Strength is set to 1. Now the most important thing, the mask node. Open it up and set it up the mask value you have. Mine is red. Get the base color, since this is the attribute where we have the data. And connect it to the alpha. Connect this here, and the end result back to the base color. Save it. That's weird. Let's see it in the shader. So I switched up this. Just change it and save it now. It should be good. And this is what we should see. According to the current setup, the base color is going to affect the outcome of the mask color, which is more accurate. But if you want to fully cut out any influence and just get the pure mask, get this and plug it here. And now if I change the base color, you can see it's no longer affecting the mask at all. Let's modify the noise as well, make it much more smaller, so it will affect the strands fully scattered. If you want to use multiple channels and multiple colors, then you should repeat the lerp process. Now it's just a matter of time to setting up the color according to the reference. Okay, so this is what I come up with for now. I also want to show you that, for example, what this value does. So this stabilize rasterization, without it, the hair looks way better and not looking that pixelated. However, for example, at the eyelashes, it can be a good addition. Now let's do the haircut and helmet generation now. For that, we will need to go back to our Unreal 5.5 project. Here, let's import our grooms that we exported from Blender. I also already have the plugin enabled. Now here, to be exact, we need to set up the same thing just like the last time. But this is only for demonstration purposes, so I'm not going to do that now. I'm going to add the materials. And here at the card asset, get the material hair cards. And now we can generate the hair card assets. We can customize this as our hard content, but this is perfectly fine like this. And after a few minutes, we got our maps and mesh as well. Let's go ahead, asset actions, and export all of it. Nothing special needed to be set. Now the helmet mesh. For that, drag the strand groom to the scene, change this to modeling, go to Grooms. Oh, and you need this plugin for this to work. So we can see a helmet here. If I hit it, we can immediately see it created a nice helmet for the lowest LOD for us. Check where the system placed it and place it in your folder to find it. Then export it out just like the card mesh. And that's it. Back in 5.6 project, I create a new folder and import all these new assets now. We can ignore these warnings and now we can actually add something here at the cards. Add the hair card material, and we can drag and drop the mesh here. Now since the hair has two parts, I should have created separate mesh cards for them, one for the front and one for the back. And then here I would able to set the group index to 0 and 1. The LOD index obviously determines at which LOD this mesh should show up. You will get it in a second. The meshes, let's add a mesh asset. Select the helmet material, then add the mesh itself. Now go back to LOD. Let's add one here. So this is the front hair. And let's add here one as well. So now both the front and the back of the hair has LOD1. The way it should be, as I said, it should be in two separate meshes. Therefore, at the back of the hair, I'm going to turn off visibility, since I didn't create a separate mesh for it. However, up here, at the front hair, I'm going to select LOD1 to cards. And if I change this to LOD1 up here, we can see that only the back of the hair is visible, but it's actually not. It's kind of confusing, but that's because of the group index, and I should have created it separately. So we should ignore that. The main point is if I change this LOD index to 1 now, we can see that the hair cards actually become visible now. If I change this to group index 1, then nothing will be visible since it turned off in the LOD settings. Now down below here we have our textures. Actually the asset in our cheat folder use compact card mode, so we should have used that when we generated the cards, but we can do that like this as well. Just change it back and place them in order. This is what I said, that you have to set them the same settings here as well, since the width is not matched at all with the cards, but as I said, it's just demonstration. So helmet is exactly the same thing, you just have to select the right LOD index and IDs and set up the LODs for it. But I don't need any of the lower LODs, so I'm going to remove this and move on. So again, we go into our cheat folder and now we can look up the hair wardrobe items if you would want to. And we can see under Groom there are some things that we don't have, like this bake texture. It's going to work without it, it's more like an FYI. Now I will create 3 wardrobe items for the 3 grooms. Open up, get the Groom binding here, and copy and paste pipeline from here. Now this is what I said we don't have, so we are actually using here another assets stuff, but as I said, it's going to work. The reason we want this is to be able to modify this asset inside the creator. We can save and close this. I'm going to copy the binding from here to my brown hair, open both wardrobe items, and as a matter of fact, did I use the Groom binding or the asset for the eyebrows? I didn't, so let's switch this. You need the Groom binding here, and now we can save and close it. And for custom hair, I can simply just choose Groom pipeline here and here as well. I could be able to add any instance here, but I'm not aiming for that dynamic changing. Copy all the stuff from the original hair. As I said before, beware that these are not actually our stuff here, but we can ignore it. Save and close everything. I remove everything from the scene, and here comes the moment of truth. Go to hair and clothing section. Put the slider all the way down, and here at the clothing, let's start adding the wardrobe items. Let's double click them. And as I can see, they are all fitting nice. I will check the other outfit. Okay, seems all of them is fitting. Now we could update our skin materials here in the material section, but it's very limited and it's way easier to do it after the assembly. I'm just going to give her an eye makeup for here because she's rarely seen without makeup. Now back to the hair, let's start adding the grooms. Eyebrow to the eyebrow. Double click. Seems it's perfectly fitting. And in the details, you can see we can actually modify everything, just like at the normal groom. Now add the 2 hairs as well. Let's apply the custom one. And it looks exactly as it should. If you see clipping, it's probably due to the collision radius. The only part where I didn't set Niagara physics is on the top of the hair. Seems quite fine. And you can see that we can't modify this hair, obviously, since I didn't set dynamic changes inside the wardrobe. Let's go ahead and test everything in action. So let's create a full rig now. Once it's done, on the right side we have different animations. Let's hit play. Seems okay. Let's look at it with some more dynamic movement. There is a little bit of stretching at the T. It's not big of a deal. Oh, hello. It does seems like it's working. Let's see the face ROM. Seems perfectly fine for me. Now we will remove the rig and test the other set as well. Actually, the hair with the brown is quite spot on. However, you can see I can change it if I would want to, just like at any other groom assets. And as I said, we can change values even though it's already inside the creator. For example, at the eyebrow, I changed a few things here. Seems better. Let's save it. Well, it's far from perfect, but that's not that bad either. Let's create the rig and test the movement. Check it in different light as well. The body ROM seems good as well. Hair physics seems to work just fine as well. Let's assemble it now to a new folder with EU optimized. Save it and close it. Go into the new blueprint. You can see all the cloth assets just assembled as simple skeletal meshes. For the grooms, it sometimes disappears. You can add it back here. Now let's modify the textures as well. Compile and save. Place her in the scene, reset the location. Go to the body, find the body instance, create a folder and import our textures. So these are all the ones we created. Select both of these type in the matrix and here uncheck sRGB on both. Now we can check what else different on these original textures to make everything perfect. Now let's just drag and drop the corresponding maps. Change this to mask no sRGB just in case. Down below we have a micro tiling map. Let's change it. And that's it. Save it. And we can see it's all good. We can hide the skeletal mesh for check. Oh, I accidentally imported the wrong normal and not the last one. Let me import the final normal instead. Change it. Save it. Let's check it. Now that's better. Now let's change the face material as well. I will just import the new maps for the thin and the thick one. Check them. Oh, there is a little spot here. Get back to the thin one. Looks fine, let's save. And there we go. But there is more. It's time for the ARKit and animations. Let's add a level sequence. Add the blueprint to the sequence. Remove the control rigs. Both on the body and the animation we can see we have an available ARKit mapping animation. Let's add that to the face. If we scrub through the timeline, we can see it's actually did what it should. Well, sort of. On every character you can actually find it under MetaHuman, inside Common, inside Face. Let's open this up. At first glance it seems okay. We can actually say that even though the timeline is longer, it stops at frame 53, where it should be since the first frame should be the default pose. So let's make it 53 instead of 52. On its own, if we would export this, this wouldn't do anything. We have to bake it down. I get the red marker and put it at the end of the animation. I create a folder for the animations, then right click here and hit Bake Animation Sequence. Select the folder, name it, then here, without any change, I'm going to export it. Let's open the bake sequence. Now we can see that it is working, but I'm going to get back to this soon because it's not going to work perfectly just yet. Let me show you something interesting as well. So again, we can go to the cheat folder of ours. And as I said, there is a lot of good stuff here. So actually, if you follow, you can find the ROM animations from the creator as well. This, for example, is the idle one. But again, on its own, it's not going to do anything. If I place this into the scene and add it to the sequencer, there is no actual data on it. To resize that data, go into the animation and go to create asset, create animation, current animation, and hit animation data. And let's export it. Now if I try to add animation, we can see it's there. And it's working as well. Now since we have a working animation on this, we can retarget this animation to our character. Select the body and just export the animation. Now I'm going to delete this and we can see we have an idle animation now. Now do the same on the face idle animation as well. Retarget, the target is the head obviously. Select it and export the animation. And now we will have this animation as well. If I add it to the head, just place this here. We can see it's working. And we can actually get a lot of animation from here, the body ROM and everything, which are perfect for showcase. I will do that on all of it now. If you want to do that too, the only thing you have to look out for is to make 100% sure that you are retargeting from head to head and from body to body animation. Just for demonstration, here is the body animation in action. Now I'm going to place the red marker at the end again. Since we still need to bake these animations as well, one by one if we want to use them in Blender. I create the folder and export them out again without any change in the export settings. And now I will do that on all of it. Now just to show you how powerful this folder is, in the lighting environment we can find the set it up levels for different lightings as well. So we can go into any level to render our character out. Now we will do a really quick demonstration for an actual cloth object because the tiles should be handled like that, but it would be way better with a physical based rig. But let's do that cloth now. So right click, let's create a skeletal mesh, get the chest, not the head. So then this time I'm going to select the binding as well, namely neck 1. And if I open it up and check it, the weight, it should be fully weighted only to that bone. Now I create the cloth asset, delete everything to make it easier. Cloth asset terminal, add the skeletal mesh import again. If you want to, we can drag and drop instead of selecting, then connecting it up. Get a weight map, from that get a default config, and from that get a max distance. And get a physical asset. I don't want to use physical asset just yet. So this weight map is where we paint our cloth influence, just like at the old version. I'm going to paint it like that and smooth it out. Get a body base asset here and get a running animation. Now here, let's go and tick in max distance and connect this up. And we have to name this output to max distance, otherwise it will not simulate. Now we can see that everything is working properly. And this sim config is the usual options that we use to add the cloth editor. We can go ahead and play with it or check the UE sample project file for more info on cloth behavior. Now the physical asset. Here we have to select obviously our physical asset and connect it up. However, it's not going to collide with the boobies since there is no collision there. So let's fix that. Open it up, find the spine 4 and add a sphere. Scale it and place it like so. Add another sphere and place it like so. Save it. And now we can see it's colliding properly. Save everything, then get into the blueprint and select the body and look for cloth asset. Name it and get the asset here. Compile save. I create a sequence so we can see some motion. If I just hit play, nothing will happen, but if I hit simulate, we can see that it is indeed working. Obviously I made a really trash job here with it, but you get the point. Now back to the animation and the ARKit. Let's go ahead and export the animation now. Just copy these settings. I do this on all, but keep Unreal open because we'll have a little problem with the ARKits. Now we are back in Blender and I'm going to import the ARKit first. I'm going to hide everything and show you the problem. So we can see something weird if we're going through the timeline here. It's like something is off. We are at frame 58 and still getting shapes. The problem will be the FPS. If we go into the beginning, we can see that it has an extra frame that shouldn't be there. Which connecting frames, I should say. So that's not right. Let's go back to Unreal and go into the original ARKit animation. Open it up and see what's wrong. The timeline here is okay. So we have to peek into the import data. To do that, right click on the asset and audit asset. We can find our baked animation and audit, so you can compare multiple assets this way. But what we are looking for is this import file frame rate. We can see that it has been created with 24 FPS, but probably they didn't pay attention and let the engine recalculate it to 30 FPS. I assume this is a mistake from their side since in Unreal 5.2 this method worked flawlessly. Now to fix that, just get the ARKit animation to the face, get the red line, place it at the end of the animation and set the frame rate to 24. And now we can see it look and behave as it should. If I switch back to 30 FPS, we can still see that extra frame. So let's switch back to 24. Place the red mark to frame 53. To get the exact order for these shapes, we can again peek into the mapping and we can see the whole list. However, they actually made another mistake, but I'm not really sure it's a mistake. Maybe it's intentional. So there is one shape that is actually missing from their mapping and animation. If you look up mouth, we can see that the mouse close is not here. In the facial animation video I mentioned, after retargeting, what I found is it's working better without the mouse close curve. So this is probably connected to that issue. Anyways, let's move on, and now with 24 FPS, let's bake the animation sequence. But this time make sure down here you tick bake timecode and select 24 FPS. And then hit export animation. Now I have 53 frame animation. Save it and export out this asset with these settings. Now in Blender, let's export the new ARKit animation now. Hide or delete the old one. And now we can see there is no longer extra frames here. However, the mouse close curve, as I said, is missing. It should be between 19 and 20 frames. Otherwise, all of them are working great. And we can see that the ARKit ends here, so there is no duplicated shapes. Now there is two ways to get the shape keys. You can either do it manually at the base here, then here, save as shape key, and you even have to rename it. Or you can use my script I created, which can be downloaded in a link in the description. So you just copy the script. It's actually right there that the script is going to skip the mouse close curve, so everything will be working fine. So copy it, go to script, create a new one, name it, and paste it. The only thing you need to change is the name here. So you either rewrite it here in the script or just rename your object to head mesh like me. Then hit run. And now if you check, all the ARKit shape keys are right there. And we can even export this back to Unreal and use it as a new mesh if we want to. Just show you, I duplicate the mesh, remove the rig, and you can see it's totally working without a rig as well. If you want and need the mouse close shape, then you should create it manually through sculpting or editing. Basically, that's the only way. Now I'm going to delete this extra one and get these ARKit shapes. We can simply transfer the shapes, but not with this. Instead, with this add-on, Mesh Data Transfer. Now we would need to do it one by one, but I'm lazy and I don't want to do that, so I'm going to join the whole mesh, except the extra irises, rename it just for parity. Now while our original mesh selected, we can go ahead and eyedrop the source, which is the animation mesh, then select the shape keys and hit transfer mesh data. And now we have all of it. I have one extra key here, don't bother with that. Let's check it. Seems they are all working, but the iris is not, since they don't have the data. I left it out just to show you that it works one by one as well. Join them, select the eye, eyedrop the complete head, then transfer the shape keys. Join it to the complete head, and if I check, everything is working as it should. Now we have all the ARKit shape keys. I don't really find this extremely handy in case of MetaHumans, but there you have it. And now for the animations, let's create a new folder and import the face from first. And we can see it's working. Let's find the end of the animation to loop it. Okay, seems good. Now I repeat, do not try to find all the bones and retarget the animation with Rococo, it will not work. Also, we are way too lazy for that, so there's a quick hack for it. Let me unhide the original bones as well, put it in rest pose, select the animation rig and hit rest pose on it as well. Now you can go ahead, clean and keep transform and reprint it, or you can simply go here and select the animation skeleton. And if I go to pose mode and hit play, we can see it's working flawlessly. Awesome. Now get a new collection and import the belonging body animation for the face ROM. Rest pose on both rigs. Then select the new rig. Get pose on the new bone. And now we have the full animation here. In Unreal, I'm going to simply export out the weight transferred new skeletal meshes. In Blender, just import them, open them up, select the meshes, object, parent, clear and keep transform. I go and remove the modifiers as well and place them in the new collection. Then I can delete this whole folder. Now we're going to parent them to the original body rig with armature deform and place them in that folder and delete this new one. Now same thing, rest pose on the anim rig and change the object rig on the cloth asset as well. Now we have all these meshes as well. Check it in material preview. Almost, but let's change it back to our original materials. Cool. Okay, next the hairs. Make sure you are in rest pose. You can either simply parent it to the head, but if you for some unknown reason want physics on the hair, you have to change these hair curves. Make sure your surface is applied here. Because of the export or the rig change, this can remove it from the hairs. So select the hairs, go to sculpt mode, then go here, hit convert to particle system. Go out, hide the hairs, and now we have them as hair particles on the face mesh. Same on the eyebrows. Add two materials and get your already set it up materials. In the particle system, just apply the materials logically, To simulate it, you can use hair dynamics. Here you can set various behaviors, and here at the cache, you can bake it down. But I'm not going to do that since it would take forever. Now we can check that. Our FPS is highly dropped, but there you have it. It's working as it should. Regarding the cycles here, we need to make sure that the B-spine and the steps are high enough. Because if not, you will probably see something like this. So enable B-spine, set it to 10, and steps as well to 9 or 10. Now we can see it's looking way better. But why would you want physics for this in Blender? Anyway, let's check the body ROM as well. Same thing, rest pose, and just change the rig. Now we can see this working perfectly as well. If any weight paint change needed, we can do it right here, then export it back to Unreal. For final touches, I will show you the peach fuzz. So you can either export it from Unreal as we did before, but I think it's totally pointless since we can do it faster here as well. Make sure the face rig is set to rest pose. Disconnect the hair if you already converted them to particles. Go to edit mode and select the face with L and separate it. Obviously you only need to do that if you join the parts. Remove the hair particles from the non-skin parts. Then we can reconnect the hairs to the skin. Go and create a particle system, change it to hair, create a new material for the fuzz, open the shader, and from the face LOD get the SRMF map. And plug in the alpha to the alpha. Set the roughness like so, and the specular, maybe some transmission or sheen. Select some whitish grayish color, get a color ramp and place it like so. I will hide the other particles now for more responsive viewport. Here I select the fuzz material. Down here make it interpolated and set it, for example, 5 and 5. We can lower the length. Actually I make it a bit longer to show you that without the alpha, the fuzz will be all over the face. If I plug it back in, it leaves out the eye and the mouth area. And here we can also add the curve kink and set the values like so. Something like this. Or you can simply go in the direction you want it. Let's see it in cycles. The eyes probably need adjustment on the subsurface depending on your scene settings and the chosen render type. So just add one more 0 here. It looks good. Make sure iris doesn't have it. We can see some artifact like that bluish tint here. It's because of the joining. That's why I said I was lazy and joined them all of it. So to fix it, I'm just going to separate the eyes. Check it again. And now it's all good. And the fuzz looks fine as well. Now I will also want to mention quickly the wrinkle maps. For example, let's use the nose sneer shape key for simplicity. Get and add the image texture and go for the DCC and look for the CM2. I believe that will be the responsible for it. And look for VM2 normal as well. Get yet another image texture and look for the mask inside the DCC. We can see that their names mentioned VM2. This even mentions nose wrinkle left. Now we have all this pegged in an RGBA texture as well, if you remember. But again, for simplicity, I use that. Get a mix color, plug this in first. Sorry for the B socket. And we can already see the result is there. Now let's connect it to the actual face skin. AO to the end always. Do the same with the normal as well. And now we can see that it's already working. Now I'm not going to do that, but I will give you a hint. If you scroll all the way down in our 24 FPS ARKit animation, you can find these curves, head CM color. This contains all the necessary data you need for the wrinkles to accurately get where and when they should be activated. If I go into 1, we can see at which frame it reaches 1. So we can determine and set this up in Blender if we would want to. But that's way too much in my opinion. But if you want to get into wrinkle maps, check my other video about it. With all that said, thank you very much if you stayed with me for this long run. Hope this video helped you out. If it did, please leave a like, subscribe, and I will see you guys in the next one.